share my screen. All right, so I will do some more problems, 12.3 and 13.2. I'm probably going to finish early, which means I'll let you ask questions. Okay. Thursday is our last regular exam, exam 5. Okay. As usual, I'll let you ask questions at the beginning, but if you want to ask as many questions today, so you can kind of get out of your system, so to speak, then we can have more time for the test on Thursday. Okay, so I'll lecture for a while. I gave you enough of 12.3 and 13.2 last time to get you started, hopefully. I'll do some more problems from both, and then after a while, I'll stop and let you ask questions from anything here, actually. Okay, so I'm going to give you some time for question and answers Thursday, but again, if you want to knock all of them off today, then I can give you more time for the test on Thursday. Then the following Tuesday is really just a review for the final. Okay, so your homework, quote unquote, is to come in with questions from the previous exams. Okay, so again, you say, how do I study for the final exam? Just look at the previous exams, of which you already have 4, and you're about to get the 5th one on Thursday. Okay, just study off of those, and I'll take questions for the entire class period for previous exams. Then Thursday the 17th is a final exam. That's all we're going to do. So no questions and answers on Thursday the 17th. So we can go straight to the final exam, and you have the entire hour 15. There's no adjustment to our schedule. It's still going to be 5:40 to 6:55. So you have the entire hour and 15 minutes for the final exam. Okay. So most likely scenarios, I'll pick some problems from every test, and then just base you off of that. So a likely scenario is something like, say we're going to have 5 tests, so maybe 3 questions per test, so 15 total seems like a reasonable way to give the final exam. So I'll look at the first test and I'll pick 3 questions from there, and then 3 questions from the second, 3 from the third, 3 from the fourth, 3 from the fifth, and that'll make up the final exam. It doesn't have to be the very same question, but it might be just adjusted. But I'm allowed to give the same question. And yeah, as far as the formula sheets, the cheat sheets, just bring all the previous cheat sheets. You don't have to reinvent the wheel. If you've already got all the previous cheat sheets, and hopefully you're building up the cheat sheet for this Thursday's test, then just put them all together. If you say, oh, I lost it, or I can't find it, then you can redo it. And by the way, you're allowed to put more stuff in. So maybe you took a test and say, oh, I wish I put that in. You can do that now. You're still allowed to do that. That's perfectly fine by me, okay? So that's all we have left in terms of what's happening. So any quick questions on what's happening time-wise and questions and answers and all that kind of stuff? So we only have 4 meetings left.
Professor Holm?
Yes.
Are we also submitting our homework on
yes,
tomorrow?
you're still. Yeah, this Thursday is a regular test. You submit the homework. You must submit at least 70% of the homework for me to grade it. Okay, but not for the final. The final, there is no homework. You just turn in the final, and then we're done. Is that right? Any other procedural questions on tests for final and so on? So again, if you can ask, so if you can ask as many questions as possible tonight, then I can give you more time to do the actual test on Thursday. Yes, somebody had a question.
So as I understand, we can take off a part of our final with our excuse test if we don't use it, right?
Yes, you actually get to drop part of the final if the final turns out to be your worst score.
So how do we go about that? Like, do we write?
You don't have to worry about it. The computer does it automatically, and I double check that. So in other words, you don't have to say, I want to drop such and such a test. The computer does it automatically in your favor. So you don't even have to think about it. Okay. Let me.
Sir, and that's just for the first 5 exams?
I'm not sure what you're asking about the first 5 exams.
You're saying that when you drop a certain grade, it pertains to the first 5 exams?
Does it pertain? It pertains to the first 5 exams and part of the final exam, but not all the final exam. Okay. Now the final exam, it's worth 200 points. That means you pretend the final exam, you're taking 2 tests. You're not really taking 2 tests, but pretend it's 2 tests. Okay, so I will give you a score between 0 and 100, like all the other tests. Okay, and it gets put down twice. So let's say on the final exam, you get 90. it's just like you took 2 tests and you got 90 on both of them. Then out of 5 plus 2, 7 tests, you drop whichever is the lowest, you see. So if the final exam turns out to be lowest, let's pretend you don't take the final exam. It's 0. It goes 0, 0. You get to drop one of the zeros, but not the other. So it's not a good strategy to miss the final, in other words. That's the way that works.
I'm sorry.
I see some
Okay,
people putting questions in the chat, but I haven't done my part yet, so I'll see if I have time to get to that afterwards. Okay, but yes, you may go ahead and put some of that in. I may be answering some of those questions right now anyway.
Yeah, what's going on Tuesday for the return exam 5?
We're going to review for the final. So your job is to look at the old exams and ask me questions about the previous exams. Okay.
Got it.
So that sheet, the sheet that you put up is a total of 800 points or 700 points?
Okay, so there's 600 points for exams, 100 for quizzes, 100 for participation. Okay, we're going to have 7 tests total. Think of it. 5 regular tests and 2 100-point tests on the final. That's not what you're actually taking, but that's how it's going to be graded as. So for exams, pretend you have 7 tests, you get to drop 1. That's actually better than if you only drop one of the 5. If you drop only one of the 5, and if you bomb the final, you have to get the whole final. If you don't understand the system, believe me, it's meant to be in your favor. It's in the student's favor.
Okay, thank you for sharing.
All right. Okay, I'm going to get started. I know some of you have some questions, but I may answer them as I do today's lecture. So let me go straight to that so we don't run out of time. Oh yeah, the quiz quickly. Hopefully it was straightforward. 3x cubed over 3, 4x squared over 2 minus 5x plus c. Simplify, x cubed plus 2x squared minus 5x plus c. Number 2, let u be all of this stuff because the derivative is perfectly this, right? So u equals x cubed minus 4x squared plus 7x. Du is 3x squared minus 8x plus 7 dx. So u to the 5th du, yes, I messed up. So u to the 6th over 6 plus c, or 1/6 x cubed minus 4x squared plus 7x raised to the 6th power plus c. So that was the quiz, and that was our last quiz. Okay, so I have 12 quizzes total. You get to drop 1 out of every 4. So quiz 1, 2, 3, 4, whichever one of those was the worst, you drop one of those. Then 5, 6, 7, 8, you drop one of those. 9, 10, 11, 12, you get to drop one of those. I'm rigging it in your favor, put it that way. Okay. All right. Okay, so now jumping back to 12.3 and 13.2. As always, you know that my questions do not necessarily have to match your questions, but you're still learning the material. Okay, so my 12.322, integral of 7x squared over 4x cubed minus 9 dx. All right, the derivative of the bottom is almost the top. And what tips me off for that is that this is x cubed and this is x squared. So I know if I take the derivative of x cubed, right, there's going to be something with an x squared. So I let u be the bottom. Du is 12x squared dx. I have 7x squared. That's going to be okay. Take the 7 out, put the 12 inside and 1/12 outside. So that way this will become u, the next step on the bottom. 12x squared dx is going to be my du. And out in front, I have 1/12 times 7, which is 7/12. So 7/12 du over u. If it's du over u, you can always sneak in a 1. That's a 1 there. 1 over u. So when I see 1 over u, that's my natural log. So 7/12 ln absolute value of u plus c. Then just change u back to what it was, 4x cubed minus 9. So final answer, 7/12 natural log absolute value of 4x cubed minus 9 plus c. Okay, 24, similar theme. 3x cubed minus 8 on the bottom, 5x squared on the top. So again, the giveaway is that that's x cubed, and I know the derivative of x cubed is going to be something with x squared. Right, so let u be the bottom. u is 3x cubed minus 8. du equals 9x squared dx. Okay, they gave me a 5, which doesn't help. That's okay, just take the 5 outside. I have x squared dx, I need a 9. So 9 inside, 1/9 outside. So outside I have a 5 and a 1/9, which is a grand total of 5/9. And then 9x squared dx changes to du. And the bottom is u. Okay. So exact same concept pretty much. So it's 5/9 natural log absolute value of u plus c. And then just change u back to what it was, namely this. So final answer, 5/9 natural log absolute value of 3x cubed minus 8 plus c. Okay, 28, again, my 28. Okay. Ignore the green and the red temporarily. The bottom has x squared. The top has x. I know when I take the derivative of x squared, there's going to be something with x. So it's a good guess to let u be the bottom, and hopefully the derivative is the top or almost the top. So let u be the whole bottom, x squared plus 4x minus 9. So my du is 2x plus 4 dx. They gave me x plus 2, but upon further examination, realized that 2x plus 4 is 2 times x plus 2. And there's the x plus 2, right? So they might not give it to you exactly, but you might have to put in a constant and the reciprocal outside. Okay, so the derivative of this stuff is 2x plus 4. I can write it as 2 times x plus 2 dx. There's the x plus 2. So we know the way it works. I need a 2 inside and a 1/2 outside. Okay, so once again, all of this will now become my du, 2 times x plus 2 dx, and the bottom is u. And the coefficient I have out in front, constant in front, is 1/2. Okay, so I got 1/2. What's I? I is the original integral. So I have 1/2 integral of all this stuff, 2x plus 2 dx, 2x plus 2 dx. That's my du, so that's du, and the bottom is u. So in green here, I have du over u, and we know, again, that's my natural log, so it's a recurring theme, I guess. So 1/2 ln absolute value of u plus c. A lot of these work the same way. And then just change u back to what it was. What was it? All this stuff. So final answer, 1/2 ln absolute value of x squared plus 4x minus 9 plus a constant c. Okay, 12, integral of 4 over e to the 1 minus 2x dx. All right, first thing I notice is that's on the bottom. So I'm going to bring it up and put a minus in front of it, right? If you have e, whatever on the bottom, bring it upstairs, put a negative in front. Okay. And then I'm going to distribute the negative sign. It makes it easier. So negative 1 minus 2x is the same thing as 2x minus 1. You can switch this around. Okay. If you see it's negative 1 plus 2x, that's the same as this. All right, so let u be 2x minus 1. du is 2 dx. Okay, take the 4 outside. 2 inside, 1/2 outside. So in front is 1/2 times 4, and 1/2 times 4 is 2. So I'm going to have a 2 e to the u du. Okay, so here we are. 2 integral of e to the u du. And what's the integral of e to the u? Itself. 2 e to the u plus c. And then just change back to what it was. What was it? U was 2x minus 1. So final answer, 2 e to the 2x minus 1 plus a constant. All right, now I'm going to go back and do some more 13.2 definite integrals. Okay, so they give me a number here and a number here. So the final answer isn't going to be blah, blah, blah plus c. The final answer is a real number. Okay, so 20, or again, my 20, 5x squared, and ignore all the red, 5x squared, 4x cubed minus 2 to the 4th power dx. So temporarily ignore the red. Okay, 4x cubed, the derivative of x cubed is going to be something with x squared. So that tells me let this stuff be u. So u is 4x cubed minus 2. Du is 12x squared dx. All right, so I needed 12. 1/12, 5 comes out. So 5/12 integral. Now here I'm actually putting x equals 0, x equals 1 to remind me that I'm doing this in u, but these numbers are not numbers for u, these are numbers for the original x. So I have to remember to switch it back. Okay, so 5/12 u to the 4th du. When I integrate, it's u to the 5th over 5. X equals 0, x equals 1. Okay, I cannot plug in right now because these are numbers for x, not for u. So I have to switch back u. By the way, these 5s cancel out, so that'll be 1/12. Okay, so notice I changed u back to what it was. What was it? 4x cubed minus 2 from 0 to 1. Okay, now I can plug in. Okay, because these are back in the original variable x. So if I plug in 1, 4 minus 2 is 2. So I have 2 to the 5th power minus, if I plug in 0, I have 0 minus 2, negative 2 to the 5th power. Ignore that. I messed up over here. So I have 1/12. 2 to the 5th is 32. Negative 2 to the 5th is negative 32. So I have 32 minus a negative 32, 32 plus 32, 64 over 12, which reduces to 16 over 3. So final answer is 16 over 3. Okay, then 24. Yes, I realize I'm kind of going fast, but I'm aiming for a quantity now because I know a lot of you have questions, so I want to get all the questions in as much as possible. Okay, so 24, the original said 3x squared minus 2 to the 4th power x dx. Okay, the derivative of 3x squared minus 2 is going to be something with an x. We know that, right? So let that be u. So u is 3x squared minus 2. Du is 6x dx. They gave me x dx, so 6 inside, 1/6 outside. So that means this is going to become u to the 4th power. 6x dx is du, 1/6 outside. I'm writing x equals 0, x equals 4 to remind me that after I integrate, I must not plug in the 4 and the 0 yet until I switch back to the original variable, which is x. Okay, so temporarily, I'm going to go u to the 5th over 5, but that's with x equals 0 to x equals 4. Okay, and 1 over 6 times 5 is 1 over 30. U, change it back to 3x squared minus 2 to the 5th power from 0 to 4. Okay, now I can plug in 4 and 0. Don't plug it in with u. That's why I wrote down x equals to remind myself, okay, I can't plug in because this says u, so I can't plug in until I switch back to the original variable. Okay, so there's a 1/30th in front. Plug in 4. So that gives me 3 times 16, 4 squared is 16, minus 2. Minus, plug in 0, I get a negative 2 to the 5th power. Okay, you get a super big number. 3 times 16 is 48. 48 minus 2 is 46. So I have 1/30th, 46 to the 5th power minus negative 2 to the 5th power is a negative 32, so it's a double negative. Okay, so you get this ridiculous number. 205963008 divided by 30 as a decimal, 6865433.6. Okay. That's the problem the book gave us, so that's what we're going to live with, I guess. So there it is. Okay, so I'll just keep bouncing back and forth and doing some more problems. More definite integrals. 26 from 13.2. Integral from 0 to 2. Cube root of 2x cubed minus 8 times x squared. Can you say, how do I know how to substitute? This is x cubed, this is x squared, right? This is 1 degree higher than this. So if I do my u substitution for this, the derivative is going to have an x squared and some other stuff, but we know what to do. So that u be 2x cubed minus 8, whose derivative is 6x squared dx. So I know that means I got to put a 6 in and a 1/6 outside. That's going to change this to du. 6x squared dx. 6x squared dx du. Instead of cube root of this mess, cube root of u. Again, write x equals 0 to x equals 2. Okay. Technically, it's not correct if I just put 0 and 2. If I just put 0 and 2, the understanding is that this is for the variable u, but it isn't. And you might be tempted to plug these numbers in for u, but you can't. These are for x. So it's to remind myself, oh yeah, I got to remember to switch back to the original x. Okay, so x equals 0 to 2. X equals 0 to 2. All right, cube root means u to the 1/3. Okay. All right, so I integrate that. Integral of u to the 1/3. 1 more than 1/3 is 4/3. U to the 4/3 divided by 4/3 means times 3/4. Play that game again. And there's a 1/6 out in front. So what did I do? I cancel 3/6 comes out to be 1/2. So that now becomes 1/8. Now change u back to what it was. It was 2x cubed minus 8. So 2x cubed minus 8 to the 4/3. Now I don't have to write x equals anymore. It's obvious. We know we're doing the variable x. Okay, so I plug in 2. 2 cubed is 8. 8 times 2 is 16. 16 minus 8 is 8. So 8 to the 4/3 minus, plug in 0, negative 8 to the 4/3. Okay. 8 to the 4/3 means take the cube root of 8. What's the cube root of 8? 2. Raise it to the 4th power. 2 to the 4th is 16. This one means this. Cube root of negative 8. And then raise it to the 4th power. The cube root of negative 8 is negative 2. What's negative 2 to the 4th power? Negative 2 times negative 2 times negative 2 times negative 2 is positive 16. I have 16 minus 16, which is 0, and 1/8 of 0 is still 0. So the answer to that one is just 0. Interestingly enough. Okay. Integral from 1 to 5e. 3y to the negative 1. Y to the negative 1, think of it as 1 over y. That's my natural log. 3 ln absolute value of y, at least temporarily. Okay, plug in 5e. E is about 2.7. So its absolute value is 5e. And if I plug in 1, the absolute value of 1 is 1. So after you plug in here, you drop the bars. So 3 times ln 5e minus ln 1. Natural log of 1 is 0, so that just drops out. So final answer is 3 ln 5e. Okay. Okay, so let's see. I was going to do just a few more, and then I'm almost done. Then I can go ahead and take as many of your questions as possible. 13.2, number 5. Integral from 2 to 4 of x cubed dx. Right? So remember, the answers to these are not plus c. You integrate x to the 4th over 4 the funny looking S moves to the right side and straightens out, it means plug in the top number, plug in the bottom number, and subtract. And if you divide by 4, you multiply by 1/4, right? So I factor out the 1/4. So it's 4 to the 4 minus 2 to the 4th. Okay, 4 to the 4th is 256. You can punch it in your calculator. 2 to the 4th is 16. So I have 240 divided by 4. It comes out to be 60. Okay, 9. You're going to go from 1 to 4 of 10 minus 4x dx. So I integrate. Integral of 10 is 10x. Integral of 4x. 4x squared over 2, but 4x squared over 2 is negative 2x squared. Straighten out the s, move it to the right side, 1 to 4. Okay, plug in 4 minus whatever you get when you plug in 1. Okay, plug in 4. 10 times 4 is 40. Put a 4 here. 4 squared is 16. 2 times 16 is 32. So 40 minus 32 minus, plug in 1. 10 times 1 is 10. 2 times 1 is 2. 10 minus 2. 8 minus 8, 0. Answer is just 0. Okay, my 15. Integral from 1 to 3 of 3y to the negative 2, that's a negative 2, dy. So power root, 3y to the negative 1 over negative 1, from 1 to 3. Okay, 3 divided by negative 1 is negative 3. Maybe I should put one more step in here. It's negative 3 times 1 over y, from 1 to 3. 3 divided by negative 1 is negative 3. Y to negative 1 means 1 over y. Okay, so I factor out the negative 3. Plug in 3, I get 1/3. Plug in 1, I get 1. So 1/3 minus 1. 1/3 minus 1 is a negative 2/3. So negative 3 times negative 2/3 is a positive 2. All right. And then the last one I was going to do is my 13, and then I'm finished. Okay. So after I do this one, I'll go back and check the chat for questions and answers, but otherwise I'll be done. Okay, so my 13, integral from 0 to 5, 4 times cube root of x squared dx. So integral from 0 to 5, 4x to the 2/3 dx. Okay, power over root, power root. Okay, power root, bump up the exponent by 1. What's 1 more than 2/3? 2/3 plus 3/3, 5/3. Divided by 5/3 times 3/5. Don't need the plus c. Okay, so this comes out to be 12 over 5. Plug in 5. 5 to the 5/3. Plug in 0. 0 to the 5/3 is 0. So this is sort of the answer, but you can clean it up a little bit. And here's how you do it. 12 times 5 to the 5/3 divided by 5, right? What's the exponent understood right here? 1. There's 1. How come I write it like that? Because then I can combine this. So 5 to the 5/3 minus 3/3 is 2/3. So best final answer, 12 times 5 to the 2/3. And then you can stop there. You just leave it like that. Okay, that's it for my formal lecture. Now let me check the chat, and the unfortunate thing here, of course, is that when you ask for a question, it's not the same as mine necessarily.
Professor Holm,
Yes,
can I take a picture of the one that's that you
Oh,
did
can.
just now?
okay, I mean, it's still being recorded also, so
Oh,
check the recording also.
no, I want a number 15.
This one?
Yes. Thank you. 1 second.
Okay, let me check the chat now. Okay,
Okay,
so
1 second, 1 second, 1 second.
12.2.
Okay.
Okay,
All right. Thank you.
all right, welcome.
Professor, can I take a look at number 30, please? You went over that so quickly.
Number 30. It's hard now because I put it away. Once I put it away, it's hard for me to get it back. And I know I'm going fast, but I have to go fast. Like I said, I have to go for quantity.
Thank you.
I gotta make the chat box smaller here, unfortunately. Okay.
Thank you. I
All right.
appreciate it.
Okay, now let me see. 12.228. So here's my 28. And if it's not this one, do you see around there? Whoever asked for it? I think I already did that one. Okay. Whoever asked for 28, can you see if this is the one or if it's not? If I don't hear anything, I'll just go on.
It's not. I don't know who asked for that.
I asked you that. It's 26. Yours 26.
My 26? Okay, so you want me to do this problem?
Please.
Okay, so I will write 28 because that's what it is for the majority of you. 2x to the fourth plus 3 squared. (8x dx). Yes, the only way to do this one is to just multiply it out. Okay, you just have to multiply it because a u substitution doesn't help. The derivative of this will be x cubed, but I don't have that. Okay, so I'll just have to multiply that out. So if I square this, it's going to be 4x to the 8th plus 2ab, 2 times 2 times 3 is 12x to the 4th plus 9, and then multiply that by 8x dx. Okay. I'm using the formula for a plus b squared is a squared plus 2ab plus b squared. Okay, and then I just distribute. So 32x to the 9th. 12 times 8, so 96x to the 5th plus 72x. So there we go. So 32x to the 10th over 10, 96x to the 6th over 6, 72x squared over 2 plus c. Clean it up. This is 16 over 5. This is 16. This is 36 plus a constant. Okay. And let's see, 12.3, number 12 was asked for. Okay, I'll show it to you, but if your 12 matches my 12, I just did that. So whoever asked for this 12, is it the same problem?
Professor, you just did it in the class, so.
I understand. I'm asking the person, is this the same as in your book? Okay, I don't hear anything, so that means I'm just going to go on. Okay, 13.222. 13.222. Okay, does that 22 match? Whoever asked it, or somebody, please?
I didn't see that. I think, yes, that's 22 is supposed to be your 18.
Okay, so my 18 is your 22, correct?
Yes.
Okay. $13.222. Interval from 0 to 3. 2x minus x squared to the fourth. 1 minus x dx. Okay, so the derivative of x squared is x, so let's let u be this. U equals 2x minus x squared. The derivative is 2 minus 2x dx, which is twice as big as this. So if I factor out a 2, I have 1 minus x dx. Okay, so now it's perfect. So multiplied by 2 and 1/2. So the integral, whoops, I have the ink there. 1/2 integral x equals 0 to x equals 3. 2x minus x squared, which is now u to the fourth. 2 times 1 minus x dx. 2 times 1 minus x dx du. So 1/2 u to the fifth over 5 as x goes from 0 to 3. And now I change u back to that. And 1 over 2 times 5 is 1/10. So 1/10 blah, blah, blah to the fifth power. And now that it's going back to x, I can just not put x equals. We know this is going to be x. So what was it again? 2x minus x squared? Okay. When I plug in 0, you get 0, right? 2 times 0 is 0, 0 squared is 0, 0 minus 0 is 0. So it's going to be minus nothing. So that part's easy. So the 3, 2 times 3 is 6, minus 9. Put a 3 here, right? 2 times 3 is 6, minus 3 squared is 9, to the fifth power. Oh boy. Minus nothing. I guess I didn't need that much space. But anyway, equals 1/10 of negative 3 to the fifth power, negative 243 divided by 10. And then we can just stop there for that one. Okay, let's see, 13.228. Can you see it there somewhere?
It's your
It is.
number 26, I think.
E
Your
to the fourth
26
minus
is, yeah, your 26
my
is
26 is your
28.
28, okay.
Yes.
E to the 4x minus 3. Okay, so u equals 4x minus 3. Du equals 4 dx. 4 1/4. Integral x equals 0 to x equals 2. E to the u. 4 dx is du, which is 1/4 integral of e to the u is itself. E to the u as x goes from 0 to 2. Change u back to 4x minus 3. Zero to 2. Factor out to 1/4. Okay, plug in 2. Let's see, 4 times 2 is 8. 8 minus 3 is 5. E to the 5th. Plug in 0. 0 minus 3, e to the negative 3rd. And that is that. And let's see, 13.230. Well, does this 30 match?
No,
No?
your 30 is our 32. So the 30 will be probably your 28.
Okay, does that look like it? 28?
Yes,
Okay, if it is, I did that earlier today.
yes.
Look back, we did that one. Okay. All right, let's see, 13.2, number 8. Okay, so whoever asked for 13.2, number 8, can you check the number 8? And if it's not that one, is it close by? Your number 8? Anybody? If I don't hear anything, I'll just go on.
I don't know who requested that. They don't say anything. 13.2.
Professor, I don't see that one on your list.
Okay, then why don't you just read it to me? Can you just read it to me?
It's the one with 24W.
Is it Nadia, maybe? Nadia, can you just read it?
So it's an integral from -1 to -2, -2 to -1, 24W to the -2, dW.
Like that?
Thank you.
Okay. So 24W to the -1 over -1, -2 to -1. Got a lot of negatives here. So -24 times 1 over W, -2 to -1, -24. Okay, plug in -1. 1 divided by -1 is -1, minus, plug in -2, I get -1/2. So -1 plus 1/2 is -1/2. So -24 times -1/2 is a +12.
Thank you.
Okay, welcome. And let's see, 13.2, number 12. 13.2, number 12. You see it anywhere? Your number 12?
It's the same one, Professor. The
So
same.
do my number 12, in other words. Do my number 12. 13.2, number 12. 0 to 2. X to the 4th minus 5x cubed plus 2x. Okay. X to the 5th over 5 minus 5 x to the 4th over 4 plus, okay, 2x squared over 2 is just going to be x squared. I'll just go straight to that as a shortcut. 0 is easy. 0 minus 0 plus 0, it's 0, right? Put a 0 here, put a 0 here, put a 0 here, 0 to the 5th power is 0, they're all 0. So the only thing of substance is 2. 2 to the 5th power, 32 over 5, minus 5 times 2 to the 4th power is 16 over 4, plus 2 squared is 4. So 32 over 5 minus 5 times 4 is 20, plus 4. 32 over 5 minus 16, 16 over 1, times 5 times 5, (32 minus 80 over 5, negative 48 over 5.
Thank you.
Okay, welcome. And let's see.
Professor, what is the 2x squared over 2 is doing up there?
I wanted to go straight from 2x to x squared. I didn't feel like writing all this over, so I got lazy. 2x squared over 2 is the same as x squared.
Okay.
The integral of 2x is x squared. Some of you already realized that, so if you want to jump straight from here to here, you may. Remember, how do you double check? Okay, derivative. What's the derivative of x squared? 2x. If you go formally by the power rule, you go 2x squared over 2, right? And then the 2's cancel out, so you have x squared.
Thanks.
Okay, let's see. All right, welcome. 316, 13.216. There's my 16.
It's yours, 24.
So my 24 is your 16.
Yes.
Okay, that is so weird. I don't know why the book does that. And I don't know why City College didn't give me the right book, but we're living with it. 1 to 2, 5 over z cubed dz. Okay, so bring this upstairs as z to the negative third. 5z to the negative third dz. So 5z to the negative 2 divided by negative 2 from 1 to 2. Clean up the algebra. Negative 5 over 2 times 1 over z squared from 1 to 2. Negative 5 over 2. Plug in 2. 1 over 2 squared is 1/4. Plug in 1. 1 over 1 squared is 1. 1/4 minus 1 is negative 3/4. So negative 5 over 2 times a negative 3 over 4 is a positive 15 over 8.
Thank you.
All right, you're welcome. Whoops. Can't see this. Okay, let's see. 12.131. $12.131. Okay, is this the same one or is it nearby? 12.131?
That's the same one.
Same one? Okay. So the basic idea is you have to divide them out. X plus 1 over x cubed. If you just do true division problems, you divide that, and you divide that, right? So x divided by x cubed is 1 over x squared. And 1 over x cubed is 1 over x cubed. Okay, and then I would need to bring both of these upstairs as negative exponents. So x to the negative 2 plus x to the negative 3 dx. Okay, so that should do it. So power root, x at -1 over -1, x at -2 over -2, plus a constant. This is an indefinite integral. That means there's no numbers here. So your answer is going to be blah, blah, blah plus c. For definite integrals, there are definite numbers. Your final answer isn't a bunch of functions plus a constant. Final answer is just a real number. All right, clean that up as -1 over x minus 1 over 2x squared plus c. And there we go. Okay, the next one is 12.221. 12.221, what time is it? 6:35-ish. Okay, 12.221, I think it's the last one from the chat. So if you want to ask more questions, you may, otherwise we're done. You can still ask questions next time, but again, the more we do today, the fewer we have to do Thursday, so that gives you more time for the test, that's all. Okay, 12.2, number 21. Okay, this is what I see. So does that one match? Or if not, is it nearby?
It's 19.
My 19?
Yeah.
Okay, so my 19. X cubed minus 1. Like that? Okay. If you can't hear me so well, yes, that's been happening. I can't do anything about it. This is the computer that school gave me. So am I breaking up a lot? Yes. What am I going to do about it? I can't do anything about it unless school wants to give me a better computer, but I don't think they're going to do that. So sorry, you might have to live with that. You've kind of survived the whole semester on that. Yeah, I listened back to the video. It's not that good quality, unfortunately. So yeah, the derivative of that is going to be probably that. So let u be x to the 4th minus 4x plus 3. Du is 4x cubed minus 4 dx. Now let's see, they give me x cubed minus 1. If I factor out a 4, I get x cubed minus 1. Perfect. X cubed minus 1 dx. All right, 2 comes out. I need to have a 4 inside. So 4 inside means 1/4 outside. So 4 x cubed minus 1 dx, that's du. Again, don't worry about the order. You say, oh, they're not even together or they're mixed up. They're not next to each other. It doesn't matter, right? These can move around. So that's du and that's my u. Okay, so 2 times 1/4 is 1/2. All right, 1/2 integral of this mess is now u to the -5. 4 x cubed minus 1 dx, 4 x cubed minus 1 dx du. Okay, perfect. So 1/2 u to -4 over -4 plus c. Let's see, that gives me -1/8, right? And the original problem had a negative exponent. Therefore, I'm allowed to leave my answer with a negative exponent, right? Remember we talked about that? So -1/8, -4 plus c is allowed in this case. But if you want to switch it back so that this is on the bottom, I'll always let you do that. Okay, let's see, what was my u? This stuff. So x to the 4th minus 4x plus 3. And there we go. All right, I believe I've caught up with the chat. If I missed something from the chat, ask again or unmute yourselves, but otherwise I think I'm caught up. Okay, so any more questions? You can either unmute yourselves and just ask me verbally or put it in the chat. Otherwise,
Yes,
we're
I do.
finished.
I do have a question.
Sure.
Professor Holm, how do you know that you know, you have to use the u and the du and then the fraction that you separated. And in some cases in the chapter 13.2, some of them you use with du and u, and the others you don't. So how do you know which one to use and what to do with the?
So how do you know? Normally, when you're multiplying or divide something and you see a function and its derivative, so like here, right? X to the fourth, the derivative is x cubed. That is a dead giveaway to me, right? You see a 4 and a 3 or a 3 and a 2. Otherwise, you have a very complicated expression. Now, let's take a look at, say, this one. This is already good to go. I'm not multiplying or dividing anything. I could use the power rule there, power rule there, power rule there. Okay. This, however, is much more complicated. So that tells me that I need to do a u substitution. And I do see a function with its derivative, almost, because the derivative of x to the fourth will have an x cubed. So that's how it works in general.
How would you decide that multiply by 4?
Multiply which by 4?
1/4 and 4.
Oh, right here. Yeah, the derivative of this is 4x cubed minus 4, which factors into 4 times x cubed minus 1. And I noticed,
So you
oh,
use the
perfect. They
4.
gave me the x cubed minus 1. They did not give me the 4.
Okay.
So that's why I have to put a 4 there and a 1/4 there.
And then it should be 2/4, right? And then you
2/4.
and become 1/2. Okay.
Yeah.
All right. Thank you.
All right, welcome. Anybody else? Either unmute yourselves or chat, otherwise we're finished. Again, you can ask again on Thursday, but again, the more we get rid of today, the less we have to ask Thursday, so we can go straight to the test. Okay, so it is a regular test though. For the regular test, you still owe me all the homework. So if you don't turn in at least 70% of the homework, I don't grade your tests. Remember, that's the ground rules. So what do you submit? All of this. I guess I should check it off. We checked off everything. We're done with the course, folks. Okay, so this is what you turn in, these 4 sections. Okay, but for the final exam, there's no homework to turn in, of course. You just turn in the test, and then we're all done. Right? Okay, anybody else? Otherwise, we're done, folks. Okay, I hear nothing and I see nothing, so that means we're done, folks. All right, so you can still ask on Thursday, but otherwise we'll go straight to the test on Thursday, okay? All right, that'll be it for tonight, folks. So everybody have a good night and study for the test, and we'll see you on Thursday. Okay, all right, good night, everybody.
Professor Hong.
Bye.
Thank you.
Thank you.
Bye, thank you.
You're home? Are you there?